Alright, so what we need to actually do here, question number 7. First, let's read the question. A medical technician uses a pair of 4-inch long tweezers to remove a wood splinter from a patient. A technician is applying 1 pound of squeezing force to the tweezers. If more than 1/5 pound of force is applied to the splinter, it will break and become difficult to remove. So the first thing in number 7 it's asking us to do is to sketch and annotate the lever system described above. So you think about what a pair of tweezers looks like. And I'll just draw a pair of tweezers here, right like this. Now, we're going to pull a splinter. So I'm going to draw my finger over here, got like a little fingernail, and a splinter stuck in that finger right there like that, right? Now, where do you think that the forces are actually going to be applied at here? We've got a couple different forces that we need to think about, and we've got a couple of distances that we need. So first off, if you think about the way a pair of tweezers work, you're going to pinch down here in the middle. So we got a force being applied here in the middle of those tweezers, right? You think that's our effort force, or is that our applied force? Or we got our resistance force or our effort force? Yeah, so this is our F of E, our effort force. And our resistance force is going to be over here in the actual splinter as far as the resistance force. And we're told that if more than 1/5 pound of force is applied to the splinter, it will break. So we want that resistance force to be 1/5 of a pound. I'm doing that in a fraction, but I can also do that as a decimal. So, Christiana, what would the actual decimal be of 1/5? No, we take the numerator. In order to convert, we need to take the numerator, which in this case is 1, and divide by the denominator, which is 5. So 1 divided by 5, it becomes 0.2. 1 divided by 5 is 0.2. So that is our resistance force. And we also, from what it is telling us, we've got 4-inch long tweezers. So go ahead and label our distance here. Is this our D of E or D of R? The distance of our resistance, or is this the distance of our effort? Okay, we'll go with D of E first, and we'll see. And that is 4 inches. And that's from one side of the tweezers all the way over to the other. So we've got a few things there that we think, and we need to really kind of find out. We want to find our distance of the effort force. We need to make sure our distance of the resistance force. We want our force of the effort and the force of the resistance are all things that we need to find. And we see that our force of the effort in the problem is 1 pound. So our force of the effort is 1 pound. We also know that our force of the resistance is 0.2 pounds. So we got 1 pound and 0.2 pounds. Now it's asking you here, what is the actual mechanical advantage of the system? You remember, what is the formula for actual mechanical advantage? AMA equals, yep, force of the resistance over the force of the effort. So I've got that. All I need to do now is come back over here and substitute and solve my AMA. My actual mechanical advantage is 0.2 over 1. All you do then, just plug and chug in your calculator. 0.2 divided by 1 still becomes AMA equals 0.2. Alright, so that's our actual mechanical advantage. Now, it's also going to want to know, as we turn the page, using static equilibrium calculations, calculate how far from the fulcrum the tweezers must be held to avoid damaging the splinter. Now that's static equilibrium. That means our IMA, the ideal mechanical advantage, is going to equal our AMA, the actual mechanical advantage. So IMA equals AMA, or we can also put this, what does IMA equal? What is our equation to come up with IMA? I'm a deer, right? So IMA, we just substitute, I'm a deer, so DE over DR, and for AMA, we'll substitute AMA equals free, so F of R over F of E. Now we already know FR over FE is 0.2, and we know, do we know DE or DR? Yeah, DE is what? DE is 4 inches over DR. So we need to figure out what the distance of our resistance, or how far away the technician is going to have it. Well, now here all we have to do is do simple algebra. So take both sides times DR. We'll get DR canceled out on this side, and then take both sides and divide both sides by 0.2, and you end up with 4 inches over 0.2 equals DR using our algebra. So 4 divided by 0.2 equals 20 inches. Now ask yourself, does that make sense? No. So what do you think we got mixed up here? Because our total length of the tweezers is only 4